first of all, let's talk about grids. So we already, what kind of grid is that we use?
Parallel.
Linear? 8x1.
What did you say? Masako, I might have.
No, we both said parallel.
Nope, not a parallel
Is it
grid.
like a portrait?
Nope.
One
Focus
direction.
grid. A focus grid.
Oh.
Okay, so what's a focus grid?
The-
Most all grids are focused.
The
by
lines
the
go
way.
with the beam.
Good, okay, so if you're looking at me and I'm the grid, the lines go with the divergence of the beam. So the beam goes like this when it comes out, right? Okay, so a focus grid goes like this.
So like they're not all sitting at the same angle. They all kind of
Right.
are slightly different.
The ones in the middle are perpendicular, and then they go out like that with the divergence of the beam. Okay, they're wonderful because they really clean up a lot of scatter, but they're bad because you have to be almost perfect with what you're doing. Okay, so the first one we just did it, and we did just a regular shot with the grid. The second one that we did, what was the second one that we did?
That was really far, I think.
Not really close.
It was really
25,
close.
I think.
Yeah, so number 2 supposedly was when we went to 25 inches. Well, a focus grid is focused at usually between 40 inches and 72, because that's the range that you use, right? Okay, so we went to 25 inches because I want you guys to see where the grid cutoff is. Okay, so the grid cutoff, so in the middle it's going to be fine, no matter if you're 25 inches to it or 70 inches to it. The middle is going to be fine because the beam always comes straight down. But on the lateral sides, if you're off focal range, that's where you get grid cutoff. Okay, so you guys are going to have to know the difference. Like if this is an image on the registry, it's going to say, what'd you do wrong? Okay, so you're going to have to know the difference. Okay, so this is off focal range, right? Lateral edges have a decreased density. Okay. Then we did one, I have to find the one that is, I have to look for it, I don't know if we printed it. Then we did one where we angled against the direction of the grid lines. Those have overall grid cutoff. See how it's overall gray? So the lines are like this, and we angled like this. Okay, so you're gonna get grid cutoff across the entire thing. So angling against the grid lines, you get grid cutoff across the entire thing. And I don't think we printed the one. Okay, so if you turn the grid upside down, what do you think is gonna happen?
The divergence split.
The divergence is gonna be exactly opposite. So is it gonna be okay in the middle?
It still will, because
Yeah.
it's so parallel.
It's gonna
Or
be okay in the
perpendicular.
middle. On the edges, it's severe grid cutoff. Because instead of going like this, it's like this. Okay, we didn't print it out. All right, so these three, those were the grid cutoff stuff. The other way that there's grid cutoff is, here's my grid, okay? Instead of my tube being directly over the grid, for some reason, like let's say it was a bucky, you did something in the bucky, and you didn't center. I tried to do it, that wouldn't shoot with me messing it up. But let's say that the tube was centered over here, it wasn't even centered on the grid. Okay, that's another one where you get overall grid cutoff across the entire thing. Terry hasn't done this yet, right? She will, okay? So, because you have to know what they're gonna look like, all of them. Okay. Is there another grid cutoff? Upside down, against the direction, off focal range. That's it. Okay. So the next one was the one that didn't really work. So that was where we supposedly took a regular image, 50 kVp at 3.5. is.
Is that a bad angle?
Stop pressure.
Plate was upside down. See this? That's the back of the plate. So you guys were saying you accidentally had the digital plate upside down, you saw little funky, little funky things in it. This is a regular plate or cassette, not digital, upside down. Okay. The next one that we tried to do. So we shot a regular hand with a regular technique. This is in the old room. Okay, and then I wanted to double the receptor exposure. So you can do it either one of two ways. You can either double a mass or increase the kVp by 15%. So if we were doing it, we started out with 50 at 3.2. We doubled the mass. We used 50 kVp at 6.4 if we could get it, okay? Which we could in the other room. So with this one, we kept the kVp or the mass the same, 3.2, and we just added 15% to the kVp. So that's 50, half of 10, 15. So we added 15 to the kVp, which is 65. So this is 65 kVp at 3.2 mass. Same kind of look, doubling the receptor exposure. Okay, next one is magnification. I don't know if you guys did your magnification formula yet. Have you done that? Your magnification factor?
The SID over SOD?
So you have.
Seems familiar, but I think Carla either brushed it or the dean did, and
Oh, okay.
so that was a little while ago.
All right.
Not very thorough.
So that's the formula that you can use to figure out magnification, and I see it on a lot of registry stuff. So your magnification factor is your SID over the SOD. What does SOD stand for?
So it's the object.
Okay. So what we did was we used 40 inches SID and we used 20 inches SOD. So if you do that and you divide it, and 40 divided by 20, that's your magnification factor is 2. Okay. So a lot of times on the registry, they're not going to give you numbers to plug in. They're just going to say, okay, I put the object halfway between the IR and the tube. They didn't give me any numbers. They just said, what if you put the object halfway between the IR and the tube? What are you going to get? You're going to get double the size. It's going to be twice as big. Okay? And that's what we did here. Okay. We must have had some stuff in Q on the 14 by 17s because it's printing out a bunch of things 14 by 17. All right, so the last thing that we did, high kVp versus low kVp. So if we're talking about contrast, when I'm talking about this, I'm talking about exposure related. I'm not talking about the computer, because the computer can fix your contrast, right? They call it contrast resolution. I'm not talking about that. I'm talking about what we can do with our exposure. So high kVp gives you what contrast? Good. So low kVp gives you what?
High contrast.
High kVp gives you few or many shades of gray.
Few.
Many. We'll talk about it in a minute.
Oh, low contrast. Never mind.
High kVp is considered what scale of contrast?
The low
Long
scale.
scale.
Excellent. Long. This is short. All that means is scale. If I had a scale here and it was high kVp, you guys said there's many shades of gray, right? Okay. Over here, you guys said there's few shades of gray. That gives you a short scale. Long scale, short scale. Few shades of gray, many shades of gray. When you have many shades of gray, you have low contrast. Look at here. I can see by just looking at it. This is high kVp, this is low kVp. Look at how gray that looks. Okay. What kind of frequency do we have with high kVp?
High frequency.
Good. It's high frequency. So this is low frequency. What about energy? What kind of energy is high kVp?
High.
High energy. This is low. So that's why they say frequency and energy is directly related. If one goes up, the other one does too. What kind of wavelength is low kVp?
Short.
Short. Good. That's long. These are inversely related. Wavelength and energy is inversely related. Okay. Generally, what photon interaction is with high kVp?
Compton.
All right, heard someone say it. Compton usually produces that, or high kVp usually produces a Compton reaction. What's a Compton interaction?
Scatter.
Get a lot of scatter with Compton, don't we? Okay. What kind of interaction is usually associated when there's low kVp?
Bernstein.
You're thinking that's photon interaction.
Oh.
That's electrons in the tube. Photoelectric. We're talking about photons, because remember, photons come out of the tube. Electrons are in the X-ray tube. What kind of speed is a high kVp photon?
Fast. Well, it's the
Speed
same.
of light.
Speed of light.
Dead folio, darn it. They're the same. They're all, remember, all photons travel at the speed of light, which is c.
It's their frequency that changes, right?
Frequency, energy, and wavelength. All right, can you see the difference between high contrast, low kVp? Low contrast, high kVp. More grays, more scatter. Okay. Many shades of gray, long scale.
So I guess something that's kind of confusing that I guess this is clearing up is, so when you see like a drastically white and then black, you picture like a wider range of colors, you know what I mean? Because there's more grays in between, but you gotta think about how many colors are there, I guess, in the picture.
Right.
So,
If you see a distinct difference between black and white, that's high contrast, a few shades of gray.
okay.
Any questions? Did I bore you? Sorry that didn't work. And you know what? Actually, I wrote myself a note yesterday. I must be in outer space. It didn't work yesterday either, because I said just show the ones that I did in the old room. All that struggle, it didn't work for me yesterday either. I kept adjusting it. It's like, darn it, stop doing that. All right, that's it.